Okay, number 8 on lesson 16.1. You should be able to get through the rest of this lesson today and then start 16.2 tomorrow. So they just gave us a list of logs, and it should give you a clue because all these logs have the same base. You can apply a property we talked about yesterday. If you weren't here yesterday, I can give you the notes. 3.75, where I'm getting this information. How do I know what to do? It's all in this paper. Anybody else gone yesterday? Anybody else? And they're on the video from yesterday. If you want to look at the video and then you let me know if you need anything else. Okay? Alright. So here's you use what you remember, okay guys? At this level you can do a variety of things. You could use that change of base process and then bam, just put it in your calculator and forget the rest of the laws. But I'm going to go ahead because we have laws we want to practice. This means a multiply of the two values, and this means a division of the two values, next to each other. So we do just like order of operations from left to right. So if I do the log, they're all base 2's. So that means I'm going to take 5 times 12, then divide by 3.75. So just read it like a book. So I have the log base 2. If I do that in my calculator, I get a 16. And I do my change of logs. If I don't know how many factors of 2 make a 16, and I've got my result right there. That's all they want in the software to check to see if your thinking is correct. So you have to adapt your values, but you probably have the same process. That's not bad. You'd still get the same answer if you would have put in, these as change of base first, right at the beginning. So it depends on how potato, which way you want to go. Okay, number 9 has got 5 parts. So this is a 5 for 1. And I'll write down what they give you on A, and then I'll work it out so you'll know what to match with if you don't already. Because that's a multiply, I can change it to an addition. Of the two factors, powers, exponents. So now I can calculate, because this is all numbers, I can find a value, the log of 9 over the log of 3. Whereas how many factors of 3 make 9? Obviously, it's 2. And then I can't, simplify the log base 3 of x anymore because x is unknown. So this is the choice they give you for your first value. But this is how we got it. You break it apart, you see a multiply, you change it to an add so you can do some simplifying. They're equivalent logarithmic expressions depending on what you need. Hopefully that makes sense. You see a multiply in the single logarithm, you can expand it with an addition and simplify. So hopefully you're getting used to these laws. These laws are the ones that I'm using. I don't have to look anymore, but you could, and that's good. Look, please look. going to back up a couple of pages and write down number 9, B. Oh, here we go. This is period 5, 16.1. Okay. So now you see a base 3 of x divided by 9. So a division means I can break it apart and write it into a subtraction. Who goes first? Log base 3 of the numerator minus log base 3 of the denominator. This one we already calculated. Oh, I don't need to circle that. I'm just going to write it. Right? We already did this one. So hopefully, you do them enough. You don't have to do them over again. It's like, you don't have to write down 4 minus 2. You already know the answer. And log base 3 of x, it cannot be simplified anymore. So that's, I found to be my B. I don't know if you guys are in the same order or not. Does somebody have division for their B? Does everybody have division for their B? For their B? No? Yeah? Yeah? Okay, thank you. That's good to know. At least you don't have to figure out which one is this. Kind of cool. They're just asking you to practice the laws. I guess they call it properties. I call them laws, so whatever. Okay, this is the power. Can be written as a multiplier. We already know what log base 3 of 9 is. Remember, the answer is the exponent. I'm going to put the 2 in front, so that we have it in proper order for algebra. Algebra. Little did you know that could be simplified clear to a value 2x. See how handy those laws are? Very, very handy. I think. Chess moves. So I'm going to put the power property into play first. 9 times log base 3 of x, and that's all the farther I can go because x is unknown. Log base 3 of x. Now there's only one choice you have left of your choices. That's nice. But hopefully this says, oh, that's a single log already. What else can I do to it? Oh yeah, the change of basis property. Log of the value over log of the original base. Now my new base is 10. There you go. Done with number 9. All those. Got them all on here, but A was the addition one. And pay attention to order in the court, right? Everything has order. Have it orderly. Okay, 10 was a proof, and there's a lot of words there, but since I'm recording it, I'm going to write them all down, as much as I can to give you the right direction. And then I did find out this morning when I did it with class period 4, the typing of the number 13 was a little bit finicky. So you got all your choices for number 10, and I'll try to box out the choices. So it says let x be log base b of m, and y be log base b of n. Why would they do that? Because they want to prove everything without numbers, and it's easier to work with an x and a y than it is to work with these symbols here. So that you can rename, do the proof, and then substitute back again. So that's what they do. It's pretty cool. Okay, they want you to first of all write these two in exponential form. So it's b to the x equals m. So when theirs they have the word then, m equals b to the x. They just rewrote it like we did They took the b to the x is m, but the m was written first. And n equals b to the y. Okay. And that's the definition of a logarithm. A logarithm can be written in exponential form. Now, what do I do with those? Well, what I am proving is the quotient property of logarithms. So in my little story here, log base b of m divided by n, I substitute these two. That means log base b, b to the x goes on top, b to the y goes on the bottom. Oh, pickles. So that was by substitution. And you could do that? Yes, you can. Okay, now they're going to change this to using exponential law, quotient. If I have this like basis, I subtract the exponents. So then this turns into log base b of b to the x minus y. Because if you have a like basis, you can subtract the exponents. Then log base b of the same number leaves your x minus y solo. And then you substitute back in what you set up here. That's the same thing as x was log base b of m minus log base b of n. And you're done. You proved it. And you should have used 1, 2, 3, 4, 5, all six boxes, all 6 on your symbol bank here. There's 6 symbols. You could put them in where they belong. That's the game. You play when you prove things. Now, we proved it for all real numbers, so when you use variables instead of numbers, that means you can put in any value and it will be true. So there is no exceptions. It's amazing. And that's where they come up with this story, that when you divide, you take the log of a division problem, it's like subtracting their exponents. Because remember, these are, the answers are exponents. If you can keep that in your mind while you're playing this game, that will help you understand better. It's just not chicken scratching on a page. Okay, I think 11's a proof. With, we're proving the change of base property. One of my favorites. They say, let x equals log base c of a, and so I put c to the x equals a. Then they give you a equals, and then in the box goes c to the x, by the definition of a logarithm. So what am I going to do with that? Well, I'm going to take of a different base, log base b of a then is log, see how a is c to the x, base b of c to the x. So they just substituted, instead of a, they put c to the x. Definitely a chess move. Now I can rewrite this one more time with x out front by the power property of logarithms. Where am I headed? I'm going to solve for x. That means I have to divide both sides by the log base b of c. So my new result, if I started with log base b c of a, then that's what I let x equals. Then I manipulated the expressions so that I could solve for x. See, I moved this one downstairs. See that? Remember what x could equal log base c of a. So I just changed the basis. In our case, we usually use tens. Sometimes we could use e, but then the log base b of a over, that's supposed to be an a. My lead logged out on me. Log base b of c. This is the same thing as, I'll put what I had from x at the top, log base c of a. See? Different base. A is the now what I'm taking the logarithm of, and c is what I'm taking the logarithm of down there. So again, you just proved it for all real numbers, since we didn't use any numbers in the evidence. It's a proof. It's not just an example. Crazy how you can do that. It's definitely a game. It's a skill. Welcome to law school. That's how they do the things. Okay, 12 just wants us to describe how we can find natural logs on this calculator if this button wasn't here. So if you remember, a natural log is log to the base e. So a natural log the natural, that's supposed to be an L, is E. And I've told you that before. I don't know if you've gotten that. So now it is in symbolism. Natural log of x is log base e of x. Why are they doing that? Because they want to show you do not have to have a natural log button to push on your calculator. So it says use the change of property or change of base property. And that gives you, remember it's log of x, log space x over log space e. That's all just typed in with letters. This expression then can be evaluated for a given value of x just using the common log e key on the scientific calculator. So, and that's interesting because, yeah, if you have an E button, you probably have a natural log button, just saying, but that's okay. We'll let them prove their point. Okay, I can't put that in there. Okay, I was going to show you if I had a value of x, then I could put in the natural log of e using the E button, or 2.718, 281828. Yeah, makes that possible. Okay, this last one is it's picky on how you put it in the software. So number 13, we will carefully enter our information, and if it counts you wrong, but it was just because of a negative, the way you put the negative in, let me know so you won't get it wrong on your grade. It says complete the explanation on how to find the relationship between if I have log base b of a And what if there's a reciprocal? And you guys know that already, because we've done this. If you remember from that one one question from the last, in chapter 15, these were opposites of each other. But the guy, he forgot to take the negative, because that's how you get a reciprocal of an exponent. You have a negative exponent. So what's the difference? Let's find out. So it's another substitute and simplify. If my log base b of a, I can rewrite that as log base a over log base b. And this is all typed in already. They got this. And log, pickles. Okay, I already wrote it down. Log base 1 over b of a. I can rewrite it as log base a over log base 1 over b. So this will be your first, you got to type that in. Shouldn't have any problems with that. Just use all letters, make a little fraction down there. That's your first space. That's part 1. Now on part 2, you're going to peel this apart. I'll put that on pause. Here we go. All right, so part 2 was the picky one. It starts off with this, well, we ended up here in part 1. Log A over log 1 over b. Remember, that can equal a negative exponent, and they told you that. Log A over log b to the negative 1. And this is what they want you to put it in as. They got you the log A on top. In the bottom, just put negative log b, okay? Just put the negative sign. Don't put a -1. Don't put, I think somebody put in a -1 with a little x. They let that go. But they just put in a negative sign. And then you rewrite it so the negative's off to the side. Log A over log b. So this one goes in the software. And this one goes in the software for part 2. And if it gives you a red check, but that's what you put in, you just send me an email, and when you turn it in, say, please check number 13. And I'll see what happens. It'll only ding you, you know, a part of a point. So we write it on the bottom, because the power property lets me put negative to the left of the log, and then just the definition of a fraction. You can have a negative in the denominator, negative off to the side, or negative in the numerator. And part 3, we just proved that the log of a 1 over b, base 1 over b of a, is the opposite. See how these two are opposites? And that's good to know. It's really good to know. Really, when you're working with the numbers, it's a powerful truth. I'll stop the video and you guys enjoy finishing